Hi students, welcome to Sunil's tutorial. I'm Sunil Menwani and today we'll be doing this chapter called as definite integrals. Today we are going to do substitution type. Integral of 0 to pi by 2 sin x upon 1 plus cos x dx. Right? Now you will say, let us assume let 1 plus cos x be equal to t. Differentiate with respect to x. So dy dx of 1 is 0, dy dx of cos x is minus sin x is dt by dx. Therefore I can say that dx is dt upon minus sin x. Fine, do we get this thing clear? Now when you are substituting, you have to substitute the limits also. When you are substituting, you have to substitute the limits also. That's the key thing that you need to remember here. So what are the two values that x can have? X can have value 0 and x can have value pi by 2. Now when x is 0, substitute the value of x as 0 in this equation, 1 plus cos x. Cos of 0 is 1. Substitute x as 0 in 1 plus cos x. Cos of 0 is 1. 1 plus 1 is 2. So t will be 2. Next, substitute x as pi by 2. Cos 90 is 0. So t will be equal to 1. So when you write, you will say I is equal to, instead of 0, you will be writing 2. Instead of pi by 2, you will be writing 1. Sin x upon t dt upon minus sin x. This can be written as minus 2 to 1 1 upon t dt. Integral of 1 upon t is nothing but log t. When the limits are between 2 to 1, upper limit minus lower limit. So this is log of 1 minus log of 2, right? Minus log of 1 is 0 minus log of 2. Minus into minus plus, answer is log 2. Right? Next, let's see another sum, guys. Integral of 0 to pi by 2 sin square x cos x dx. Right? Now let us assume let sin x be equal to t. If I assume sin x as t, differentiate with respect to x. If I differentiate with respect to x, dy dx of sin x is cos x. So cos x will be nothing but dt by dx. So dx is dt upon cos x. Right? Now what are the two values that x can have? When x is equal to 0 and x is equal to pi by 2. When x is 0, sin of 0 is 0. Substitute the value of x as 0 here. When x is pi by 2, sin 90 is 1. Right? So this will become I is equal to, instead of 0 you will write 0. Instead of pi by 2 you will write 1. This is going to be t square cos x. dx can be written as dt upon cos x. So this is 0 to 1 t square dt. T square dt is nothing but t cube by 3 when the limits are between 0 to 1. So this is going to be 1 by 3 upper limit minus lower limit. The answer is going to be 1 by 3. Fine. Next, let's see another sum, guys. Integral of 0 to pi by 2 dx upon 5 plus 4 cos x. Right? Now this is a submultiple type. You will say let I could substitute I is equal to integral of 0 to pi by 2 dx 5 plus 4 cos x. Cos x can be written as 1 minus tan square x by 2 upon 1 plus tan square x by 2. Right? I'm using submultiple formula. To be precise, I'm using submultiple formula here. This is integral of 0 to pi by 2 LCM. If I take LCM, this will be 5 plus 5 tan square x by 2 plus 4 minus 4 tan square x by 2. Denominator of denominator becomes numerator, 1 plus tan square x by 2 dx. 0 to pi by 2, 1 plus tan square x by 2 is sec square x by 2, 5 plus 4 is 9 plus tan square x by 2. Next you will say let tan x by 2 be equal to t. Differentiate with respect to x. dy dx of tan u is sec square u dy dx of u. So this will be dy dx of x by 2 is dt by dx. So this is sec square x by 2. dy dx of x is 1. So into 1 by 2 is dt by dx. Therefore you can say that dx is 2 upon sec square x by 2. So you could say I is equal to integral of, you have substituted, so you have to substitute the limits also. When x is equal to 0, when x is equal to pi by 2, t is equal to. Now when x is 0, tan of 0 is 0, right? Now when x is pi by 2, this will become pi by 2 by 2, so that will become pi by 4. Tan 45, tan 45 is 1. You have pi by 2 and this is tan x by 2. I am substituting x as pi by 2. So pi by 2 by 2, that gives you pi by 4. That becomes 45 and tan 45 is 1. So therefore I can say I is integral of 0 to 1 sec square x by 2 upon 9 plus t square into 2 upon sec square x by 2 dt. Right? So in which case you will get this as 2 is out, 0 to 1, 1 upon t square plus t square dt. 1 upon x square plus a square is nothing but 1 upon a tan inverse of x by a, and the limits are between 0 to 1. So this is going to be 2 by 3 tan inverse of t. T is, we have assumed t to be tan x by 2. Right? Wait, instead of substituting, you just write this as it is, t by 3 0 to 1. Now substitute, first you substitute upper limit and then lower limit. So this is upper limit minus lower limit. So this will be tan inverse of 1 by 3 minus tan inverse of 0 by 3. Right? So your answer is going to be 2 by 3 tan inverse of 1 by 3, because tan inverse of 0 is 0. Right? Next, let's see another sum. Integral of 0 to pi by 2 cos x 1 plus sin x into 2 plus sin x dx. Right? Now first of all I'll say let sin x be equal to t. Differentiate with respect to x. dy dx of sin x is cos x is dt by dx, in which case I can therefore say that dx is dt upon cos x. Right? Now I could substitute. Then x is equal to 0 and when x is equal to pi by 2. These are the two values that x can take. Now when x is 0, sine of 0 is 0. So t will be 0. Substitute the value of x as 0 in the equation, sin x is equal to t. When x is equal to pi by 2, sin 90. Sin 90 is 1. T is going to be equal to 1. Now, we can therefore say that I is equal to integral of 0 to 1. This is cos x 1 plus t into 2 plus t, and dx can be written as dt upon cos x. So this is integral of 0 to 1 upon 1 plus t 2 plus t dt. Now I could solve this by using partial fractions. You will say let 1 upon 1 plus t 2 plus t be equal to a upon 1 plus t plus b upon 2 plus t. Therefore you will get 1 is equal to a into 2 plus t plus b into 1 plus t. Now in order to make this bracket as 0, you will say let t be equal to minus 2. So 1 is equal to b 1 minus 2. So 1 is equal to minus b, b is equal to minus 1. Let t be equal to minus 1. I am trying to make the second bracket as 0. So you will get 1 is equal to a 2 minus 1. So a is equal to 1. Therefore I can say that I is integral of 0 to 1 a 1 upon 1 plus t plus b minus 1 upon 2 plus t dt. Split the integral. So this is going to be integral of 0 to 1 upon t plus 1 dt minus integral of 0 to 1 upon t plus 2 dt. Integral of 1 upon ax plus b is 1 upon a tan inverse of 1 upon a log mod ax plus b. So this is going to be 1 upon 1 log mod t plus 1 when the limits are between 0 to 1 minus 1 upon 1 log mod t plus 2 when the limits are between 0 to 1. So this is going to be log upper limit minus lower limit, 1 plus 1 minus log 0 plus 1 minus log 1 plus 2 minus log 0 plus 2. So this is going to be log 2 minus log 1 minus log 3 minus into minus plus log 2. Right? Log 2 plus log 2 is going to be 2 log 2. Log 1 is 0 minus log 3. Log 2 the whole square minus log 3. Subtraction changes to division, log 4 upon 3. Right? Next, let's see another sum, guys. Right? Now, this finishes substitution time. Right? We'll stop this here for the day. Thank you very much.